Have you ever sat on a swing and wondered why it moves back and forth instead of side to side? It's an engaging puzzle, isn't it? You might think it's all about the way you push or the wind direction, but the true explanation is far more interesting and scientific. It's all about pendulum motion. Intriguing, right? Well, hold on tight because we're about to dive into the fascinating world of pendulums and oscillations. The key is that a swing behaves like a pendulum. A pendulum consists of a weight hanging from a fixed point by a string or rod. This seemingly simple setup gives rise to a fascinating motion that we encounter in our everyday life, such as on a swing in a park. In this scenario, the seat of the swing serves as the pendulum's weight, and the chains or ropes from which it hangs act as the rod. This rod is a fixed point that allows the swing, much like a pendulum, to move in a particular way. When the swing is pushed, it is essentially being pulled to the side, much like pulling a pendulum to one side. Upon release, the swing doesn't move side to side but swings back and forth. This back and forth motion, known as oscillation, is a key characteristic of pendulum motion, so in essence, when you push the swing, it gets pulled, making it oscillate back and forth. The middle position where the swing hangs straight down is the equilibrium position. This is the place of rest, where the swing would naturally stay if left undisturbed. It's like the calm center of a storm, the point around which all the action happens. Now, imagine giving the swing a push. It moves away from this equilibrium position, right? That's where we introduce the concept of amplitude. Amplitude is simply a measure of how far the swing moves away from its equilibrium position. Picture a pendulum swinging back and forth. Its amplitude is the maximum distance it swings from its center position, or in our case, the equilibrium. So, when we talk about the swing's oscillations, we're really looking at how it moves around this equilibrium position. It swings away, reaches its maximum distance, then comes back through the equilibrium position to the other side. This is one full oscillation. The amplitude of these oscillations is determined by the initial push you give the swing. A gentle nudge will result in smaller oscillations, while a hearty push will send the swing in larger, wider arcs. In other words, the harder you push, the greater the amplitude of the swing's oscillations. This translates to more thrilling highs and lows, making your time on the swing that much more fun. Just remember, it's all thanks to the principles of equilibrium and amplitude. Each full swing back and forth is one oscillation. Now let's delve into the concepts of period and frequency. The period is the time it takes for one complete oscillation to occur. Imagine you're on a swing. The moment you start from one extreme point and swing to the other extreme and back again, you've completed one full oscillation. The time it took for this entire process is the period. Frequency, on the other hand, is the number of oscillations that occur in a given time, typically measured in 1 second. It's like asking, how many full swings can you make on the swing in 1 second? That's your frequency. In essence, period and frequency are flip sides of the same coin. While period measures the time for a single swing, frequency counts the number of swings in a set time. Both are integral to understanding the rhythmic dance of the swing. How many oscillations happen in 1 second is the frequency. So in summary, a swing exhibits oscillating or periodic motion because it acts just like a pendulum. The seat of the swing, acting as the pendulum's weight, and the chains or ropes, serving as the rod from which it hangs, work together to create this fascinating motion. Let's quickly revisit the key points. The equilibrium position is the point at which the swing would naturally rest if undisturbed. It's the straight-down position from which all the action begins. The amplitude, on the other hand, is how far the swing moves away from this equilibrium position. The harder you push, the greater the amplitude, and the higher you go. Each full swing back and forth is one oscillation, with the time taken for this full swing being the period. And the frequency? That's simply the number of these oscillations happening in 1 second. Next time you're swinging, appreciate that you are experiencing pendulum motion and oscillating back and forth, not side to side.